let's go ahead and get started. Hello, everyone. Welcome back to the RM Karma Doctoral Students and Junior Faculty Consortium. My name is Hoda Vaziri, and I'm chair of the consortium this year. Today's topic is innovative approaches to collecting and sourcing data. We have two amazing speakers who will be sharing their research and expertise with us today. But before introducing our speakers, I would like to first thank Karma for their support and partnership with us to organize this consortium. They've been a great supporter of our division over the years, and this consortium wouldn't have been possible without them. So we have two speakers today. First is Dr. Aaron Anglin, who is an assistant professor of entrepreneurship at Texas Christian University. His research interest is in the areas of new venture financing and crowdfunding. And today he will speak to us about opportunities and challenges of collecting and using crowdfunding data. Next, we have Dr. Nan Zhang, who is a professor of information technology and analytics at American University. His research centers around data analytics and machine learning and social and behavioral science research. And today he will be presenting a talk about using organic data. So the way we are formatting today's session is that we have each presentation, each of the presenters presents their research first for about 30 minutes, and then we follow it by like a 10-15 minutes Q&A session, and then the next presentation, and then the Q&A. If we have time at the end, we will do some Q&A, general Q&A at the end if you have any more questions. So if you have any questions along the way, you can type it in the chat, although I think chat will be disabled during the presentation, but toward the end, I'll have the chat enabled. So you can start typing your questions. So we have a couple of them at the end of the presentation. So we can get right to the Q&A. So I think Aaron might be running a little bit late. We might, Nan, are you there?
Yes, I'm here.
Can you go first until we have Aaron come in?
Oh yeah, sure, no problem.
Perfect, thank you very much. So I think you have access to share your screen. Welcome, thanks for taking the time today, and I'm looking forward to hear your talk.
Well, sure, thank you. Thank you very much for the kind introduction. And I'm really glad to be here to talk about our research on validity concerns in research using organic data. This is joint work with Heng, who is also from Coast, and Betty Zhou from the University of Minnesota. What I would like to focus on in this talk is the kind of validity issues that could arise when our research deals with organic data. So what is organic data? Organic data is basically data that is not collected following a research design. So unlike in a design experiment or when you run a survey, the data you collected is basically designed in the sense that you designed the format of the data, the structure of the data according to the need of your research. Organic data is generated from, let's say, online platforms like social media, from sensors that people have on their wrist at their home. They are not really generated for the purpose of research. Instead, they are generated for other purposes, for convenience, for people to have a better life. But if we would like to take advantage of such massive amounts of organic data, out there to support our research. What are the potential validity issues that could arise is the focus of my talk today. So two specific characteristics of organic data that you will hear me say again and again today. One, as I just mentioned, organic data is not collected following a research deadline. And two, generally, organic data sets are quite large, much larger than the kind of design data that we are used to. This means that the kind of ways we use to analyze organic data would also have to shift from the small sample regime that we are all used to a kind of a larger sample regime that, for example, involves the use of computational algorithm to analyze data. So these two special characteristics you will see today are the fundamental reasons behind quite a few validity issues that could arise in the use of organic data. So first, let me clarify what I mean by validity concerns that we would like to address in this talk. Specifically, what I would like to focus on in this talk is the robustness of research using organic data. So what do I mean by robustness? If you look at this typology developed in the literature, well, if you are many of you might have heard about the so-called reproducibility crisis in psychology and beyond. And there are different kinds of concerns, validity concerns on using different kinds of methodologies for research. Now, if we are talking about whether we can reach the same research finding using the same methodology over the same data set, this is basically the reproducibility concern. If we are talking about whether we can get the same research findings by using the same method over different data generated from the same population, that is the reliability concern. If we are talking about whether we can get the same findings by using the same method over a different population, this is the generalizability concern. Now, robustness concern, which I'm going to focus on today, is different from all these in the sense that it is not really about whether if I take the method that you used and repeat what you did on either the same data set or a different data set, whether I'm going to get the same findings. Rather, robustness refers to the issue of whether I'm going to get the same research findings if I take another method to analyze the data, another maybe seemingly equally reasonable, equally effective method to analyze the data, would I be able to get the same research findings? That is the robustness concern. Now, this quote from Senator Walter Mondale seems particularly relevant here, as he was commenting that after the federal government invested millions and millions of dollars in social and behavior sciences research, he commented that for every study that contains a proposed solution or recommendation, there's always another equally well-reasoned story that challenges the finding of the first. Now, the sentence I highlighted here, no one seems to agree with anyone else's approach, is exactly the kind of robustness concern that I like to focus on today. So what happens if two equally reasonable methods actually will lead to different research findings? What is the reason behind such divergence? What is the problem that we would have to address in order to ensure the robustness of our research findings over organic data? Now, I'll talk about three main findings or three main conclusions from our study. Now, the first one, I would like to argue that robustness, not reproducibility, is the main concern for empirical research using organic data. And then I'll talk about two main reasons or two main threats to robustness in studies that use organic data. One is the opaqueness of the data generation process. The other is the algorithms being used to analyze the data. And the third one is I'll talk about how challenging it is to actually look at the design of an algorithm and then say whether it is appropriate for being used to analyze an organic data set. I will talk about some latest research in machine learning, in computer science, and we'll look at what are the challenging issues that arise in using such automated computational algorithms to analyze organic data. But first, let me give you an example just to illustrate why I think robustness rather than reproducibility is the main concern facing the use of organic data in research. Now, this is a kind of a simple illustrative example, which talks about a hypothetical research study that tries to use Twitter data to analyze, for example, let's try to measure just how similar the followers of two companies are. So let's say we look at the followers of two companies at Twitter, and then we try to look at what are the percentage of their followers that are overlapping with each other. Meaning that what are the percentage of followers of company A who also follow company B? And we want to use this percentage to gauge just how similar these two companies are in terms of their missions, or in terms of the people that they attract. Now, is this a reasonable way to measure the similarity between the followers of two companies? So the reason why I'm using this example is this seems to be a pretty straightforward way to operationalize the similarity between two companies if you are using a large-scale organic data set like Twitter. And you look at the followers and you try to see between the followers of two companies, and the percentage there is a measure of the similarity between these companies. So let's look at a concrete example. For example, let's look at the, we're trying to see whether, let's say, the followers of a automobile company is interested in, let's say, environmental protection. So our idea is let's look at what's the percentage of, let's say, Cadillac's followers who also follow EPA research, and what's the percentage of Rolls-Royce followers who also follow EPA research. Now, would it be reasonable for us to, for example, look at the findings in the middle of this slide and say that, hey, because a larger percentage of Cadillac followers actually also follow EPA research, therefore, we can conclude that compared with Rolls-Royce followers, the Cadillac followers are more conscious about environmental protection. Now, if you look at the right side of this slide, you would know that this is not a reasonable conclusion, because you would have the exact opposite conclusion if you replace EPA research with their counterpart in the European Union. In that case, you will see that a lot more percentage of Rolls-Royce followers would also follow EU's EPA than Cadillac's followers. Now, this is but one example of how tricky it is to judge whether a particular method in analyzing data, or particular design of a metric that you use in analyzing organic data is reasonable or not. And this is the kind of robustness research, robustness issues that I was referring to. So I would like you to note that in this case, certainly we know the reason why we see the kind of issues that we saw is because EPA is heavily North America-centric and the EU counterpart is EU-centric. And similarly, you have this geographic region being heavily skewed in the followers of Rolls-Royce and Cadillac as well. That's the reason why we see these kind of contradictory results by looking at the followers of the two agencies with similar missions. But the important thing I want to note here is that if you look at reproducibility, reliability, and generalizability, the method of simply counting the number of intersecting followers will all check out. There's nothing will change if you, for example, have a different sample of Twitter users and calculate the percentage of common followers. They're still going to be similar to what we see just now. If you change from Twitter to another social media account of EPA, you also are going to see same results. So there wouldn't be any kind of reproducibility, reliability, or generalizability issue here. The issue here lies in robustness. That is, if you change to another way of measuring the similarity between two companies' followers, you would likely draw different conclusions from what you just draw right now. Like if you change the method from counting the overlapping followers with EPA to gauge the interestingness of a company's followers on environmental protection, if you change the EPA from the European Union's counterpart, then you will reach a different conclusion. This is the robustness issue that I was referring to. So if we want to put a definition here, robustness is basically the extent to which research findings change as the choices we made in conducting the study vary. So if we look at the reason why I would like to argue robustness is the main challenge to research on organic data. So I would like to note that if we look at the kind of ways we scrutinize, many of you have served as reviewers before, maybe all of you. So you know the way that you scrutinize the methods used in a paper, in a study. Okay? If it's a design data-based study, if it's a design experiment, if it's a survey study, then there's a well-established principles in terms of how you scrutinize the methods being used in a study. So the method scrutinization is well established. Therefore, the main concerns, if you look at the arguments in the reproducibility crisis, is that sometimes not enough information is provided by the researchers for readers to properly scrutinize the method being used. So under-reporting is the main threat, and therefore reproducibility becomes a concern. Now, I'd like to argue that if we look at the corresponding issues in the use of organic data, we don't really have a well-established standard to scrutinize the methods being used. The example I just gave you is just one of the many examples you can find where it's not easy to actually just rely on intuition to judge whether a particular method is appropriate or not. It's this lack of understanding of whether a method is appropriate or not that is the main challenge facing the use of organic data. And therefore, the main issue that we have to address here is not really reproducibility. Just like in the example, there's not really a reproducibility issue there. The issue is whether the method being used is reasonable. It is a robustness issue that is the main challenge facing research of organic data. So that is the first point I would like to make. The second point I would like to make is there are two main threats to robustness in research using organic data. One is the opaqueness of data generation process. The other is the complexity of the algorithm being used. And this is kind of a high-level picture of how we generally conduct research. There's really not much difference between designed data and organic data. And maybe the most fundamental difference is just how the data is generated. In the designed data case, it's generated from our experimental design. In the organic data case, we say there is an underlying data generation process that we don't really understand. Just like we don't quite know why people follow a company on Twitter. We know there is a data generation process, we just don't know what it is or how complex it might be. But after we collect the data from organic data sources, the procedures afterwards are fairly similar to what we do in designed data. After we collect it, we clean up the data, we extract the values that would be useful for our research, and then we conduct the data analysis, statistical analysis, maybe machine learning algorithms, data analytics algorithms over such data in order to extract knowledge from it to reach our research findings. So basically, at a mile-high perspective, this is what we do. Right? We know that there is a data generation process, and we want to learn certain aspects of the data generation process. For example, we might want to learn, why people follow some companies, why people are interested in certain issues, or what kind of factors affect, let's say, people's activities on LinkedIn, or the career outcomes they reported at LinkedIn, things like that. Right? We want to understand a certain knowledge. We want to obtain certain knowledge about the data generation process, but we don't have direct access to the data generation process. The only thing we have access to is the data generated from this data generation process. So our job here is to basically use whatever workflow that we design, which often involves the use of computational algorithms to kind of reverse engineer this knowledge back from the data that we are able to collect. And so the data generation process is latent, cannot be directly observed. Our goal is to learn certain knowledge about this data generation process by using algorithms to process the data that we can collect and we can observe. Now, I want to talk about the first challenge to robustness of organic data use first, which is the opacity, the opaqueness of the data generation process. So again, I want to start with a simple example. So there are often a case where researchers want to understand, for example, why people access certain websites online, right? So there's some research that tries to say, for example, I guess many of you know Medium is you can say online blogging website where people post their opinions, have posts. Now, if we want to understand, for example, just how much traffic to one's Medium website is driven from MailChimp, which is a mass mailer service. And we want to know how many visitors are actually coming from MailChimp. Now, what do? And this is kind of a pretty common design that you see in many studies, which is to leverage so-called natural experiment. And for example, one day, let's say in this case, November the 6th, MailChimp went down. Went down for 2 days, so there's a sharp drop of the number of visitors to MailChimp, the number of users of MailChimp. If we also correspondingly observe a large drop of visitors to the Medium website, then a natural kind of conclusion is like this is a natural experiment. No one anticipated MailChimp would go down on November the 6th. So the corresponding drop of the Medium visitors must not be a coincidence. So we can kind of just based on this calculate how much percentage of visitors to Medium is driven by MailChimp. Now, is that a reasonable finding that we can draw from observing this time series sequence of visitor counts to these two websites? So while it might look quite reasonable, well, if we look deeper into the data generating process underlying the observed data, here's an interesting fact, is MailChimp, Medium, and a whole bunch of other very popular web services are actually all powered by a so-called S3 service, which is a storage service provided by Amazon Web Services, AWS. Which means that there's a pretty famous incident back in, I think, 2017, February, where AWS went down, so all of these websites went down simultaneously at the same time. So after knowing this aspect of the data generating process, if you look at the curves again, your understanding would be completely different. You would know that maybe this cannot be used to gauge just how many of the visitors to Medium is actually driven by MailChimp, because it could very well be that AWS went down that day. And because AWS went down, all of these websites went down simultaneously on the same day. So once again, I want you to see that what I just illustrated is the importance of having certain knowledge about the data generation process. If you don't know that it is the AWS that drives all these websites, then you wouldn't be able to tell whether the idea of using this time series sequence to derive the percentage of visitors to one website driven by another is reasonable or not. The importance of knowing certain aspects of this data generation process is the first challenge that I was talking about, the opaqueness of the data generation process. So some other examples here. The example that I just discussed about, whether we can measure the similarity between followers to two companies based on their overlapping percentage is another example. Now, if we know that the following behavior of Twitter is not just determined by a user's interest, but also determined by many other factors like the geographic region of the user. As we illustrated, whether the user is in US or in European Union has actually a significant role in determining whether the user is going to follow EPA or not. If we have that knowledge about the data generation process, then we can properly scrutinize the design of this metric. Otherwise, we wouldn't know whether it is reasonable or not. So as another example of illustrating the importance of this knowledge about the data generation process, think about a lot of research using online platforms to gauge the so-called word of mouth effect. Right? For example, after your friends watch a movie on Netflix or read a book, would it make it more likely for you to watch the same movie or read the same book? If we have the lots of these online services, Netflix, Amazon, maybe Goodreads, all these websites, then we can analyze the data and see whether there is a word of mouth effect. Right? We know your friends, what they read, and let's look at whether their reading choices actually affect yours. Now, while this sounds like a reasonable strategy to gauge the word of mouth effect, I would like to encourage you to think about what do you do when you log into a website like Netflix or Goodreads. Almost all these websites have a recommender algorithm built in, meaning that when you log in, they actually provide you with a list of recommendations. Now I want you to imagine a user who don't actually check what their friends read. They simply log into the website, whichever is recommended to them, they click on it and they watch the movie, they read the book. Now let's further think about the designers of these recommenders algorithms. Now, if these designers of recommender algorithms actually believe in the word of mouth effect, meaning that whenever your friends read a book or watch a movie, they would recommend that to you. And not knowing that, you simply go in and click on whichever is the first one recommended to you. Now think about a researcher looking at the data. Would they be able to distinguish whether there is really a word of mouth effect? That is, you read a book, watch a movie because your friend did so, or the word of mouth effect is simply something assumed by the designer of the recommender algorithms. They wouldn't be able to distinguish between these two because they would produce the exact same kind of data. But by analyzing this data, if researchers don't know that there is a recommender algorithm at play, then instead of using the data to understand knowledge of the data generation process in terms of how people decide books that they're going to read or movies they're going to watch, researchers would essentially be reverse engineering the recommender algorithm designed by that platform. So again, this is an example of how important it is that we know the data generation process. We understand just how the platform from which we collect the data actually work before we can design a robust data analysis workflow based on the data collected from that platform. This is the first issue. The second issue I want to talk about is the robustness of the algorithm being used to analyze the data. Now, this is a particularly challenging and tricky topic because unlike the previous one, which has a clear kind of recommendation, right? You need to know about the data generation process. You need to understand how these data that you observe could have been affected by various factors. This second one doesn't really have a clear recommendation because our understanding of why algorithms behave in a certain way still has not really stabilized even in the computer science community. So let me talk about the big picture challenge first before we go into some examples. The fundamental challenge here, I think, is depicted on this slide. Now, in the reproducibility crisis, for example, you might have heard about the so-called researcher's degree of freedom a lot, meaning that there seems to be a general understanding that if you can tweak a lot of the parameter settings in analyzing the algorithm, then it might give you a false sense of finding a significance after you finally find one after tweaking these parameters for an extended period of time. Right? So that is very true and very natural in the kind of statistical analysis we often use to analyze designed data. Now, if we try to translate the same thing into an analysis of organic data, so we're going to look at a feeder like this. So how do we read this? Now, the x-axis is the algorithm or the model complexity. Let's say you use machine learning, then the complexity of the model produced by the algorithm. You use a data analysis algorithm is how complex that algorithm is. Okay? So as the algorithm become more and more complex, you can certainly say that there are more parameters for the algorithm. The researcher has a lot of parameters to tweak, so the algorithm also becomes more powerful. No, that's for sure, and that's always going to happen. But what's the implication of that on robustness? Quite interestingly, if you ask this question 15 years ago to a computer scientist, a machine learning researcher, the answer would be, of course, the robustness is going to go down. We had a very strong belief in the so-called overfitting phenomenon. Right? Once you over-parameterize the algorithm or the model to analyze the data, you might fit the data that you have really well, but your results are not going to generalize to another data set generated from the same population because, well, you are overfitting the data and the generalization error to another data set becomes very high. So in a nutshell, the robustness of your algorithm is going to go down once you over-parameterize the algorithm. But if you ask a machine learning researcher today, the answer would be a lot more nuanced because as our understanding of the new machine learning algorithms, especially deep learning algorithms, improve, now we kind of don't really know how the robustness is going to change as the algorithm become more and more complex. So I'll give you some simple example first before showing some recent results in machine learning in computer science that kind of drives this point home. But basically, I don't think anyone today really understands how the robustness of an algorithm is going to change once the complexity of the algorithm goes up. That is actually an area that needs a lot of research. So first, just some examples. And this are kind of the procedure that you often see when researchers analyze, for example, Twitter data or online social media data. All the highlighted parts are basically parameters, basically design choices, right, that can be changed by researchers. Now, the point I'm trying to make here is not about whether this is good or not, but usually once you see this, you kind of have a feeling that, oh, there are a lot of parameters, right? And I want to see whether the result is robust if we change this 5 to 4, maybe to 6, and so on. That's very natural because all of us can intuitively just look at this and say, this is a very complex algorithm, and maybe there are some robustness issues potentially here. But what I want to show, what I want to focus on here is to say that it's not like if the algorithm is very simple, then there would be no robustness concern. This is kind of an example at the other end of the spectrum, which is to say, let's try to find a city in a tweet. Instead of using a complex algorithm to try to do so-called entity resolution to find the city, we'll simply do a string matching. Right? If the name of a city appears in the tweet, we say the tweet is from that city. So how about that? It's as simple as can be. Would there be any robustness concerns there? This is a study we did a few years ago, just by checking out of all the matched strings, if a tweet actually contains a string matching a particular city, then how much percentage of those tweets are actually from that city? And as you can see, the percentage vary quite drastically from one city to another, over 60% for Chicago, under 20% for Houston. Now, in particular, if you look at the case of Houston, this is the percentage of tweets posted on a particular date. How much percentage of those tweets that contain Houston actually came from Houston? Now you can see that this simple algorithm doesn't seem very robust, right? There's one day, August 9th, where this percentage suddenly drops quite significantly. And why is that? That happens to be a day, by the way, when there are a lot of tweets containing Houston were posted, and it's actually because it's Whitney Houston's birthday. Okay, so that's just an example of what kind of robustness issues may arise even when the algorithm look extremely simple. So there are a lot of similar issues that you can see that simple algorithm may not be robust, just like complex algorithm may not have robustness issues. This is another example of what kind of keywords are used by different politicians to talk about the same thing, which is the government shutdown. A few years ago, you can see that Democrats, Republicans who vote to end the shutdown, and Republicans voted to not to end the shutdown, actually use completely different language to discuss about the shutdown. So if you design a simple algorithm, just use one keyword. Let's say if you use shutdown to search for such tweets on Twitter, you would completely miss those Republicans who voted not to end the shutdown because they don't use the word shutdown that much in discussing about this event. So all these are just examples of why the complexity of the algorithm may not tell us much about the robustness of the same algorithm, which drives to my final point, which is, I think, a critical challenge facing the use of a data analytic algorithm over organic data today, especially as we are transitioning to this large sample regime, is just how exactly do we properly determine whether a data set matches well with the complexity level of an algorithm. So I want to show you some interesting results lately in the machine learning literature. This is one paper from 2018 that talks about the so-called estimation of heterogeneous treatment effects. So I won't go into details here, but I do want to show an intriguing result that was proved mathematically by the authors here. Now, generally what they say is when we analyze data, I guess a common concern that a lot of you may have experienced is people are concerned about the selection bias in the data set. Right? So in this case, because we want to estimate the heterogeneous treatment effect, the main challenge is actually whether those who received the treatment or whether those in control group were actually from the same population or if there's a selection bias. What these authors proved, however, is that if you use machine learning to process such data to estimate the treatment effect, the selection bias actually doesn't matter that much. For example, what they showed in this figure is that the so-called learning rate of the algorithm, which means how fast the algorithm can estimate and converge to the correct heterogeneous treatment effect size correctly, how fast it converges to the correct value, has nothing to do with the selection bias. What it depends on is whether the complexity of the data matches the complexity of the algorithm that you use. And so they used the so-called Holder ball in their theoretical derivations. We're not going to go into the details, but the fundamental insight from their study is that if the complexity of your algorithm matches the complexity of your data, then you are going to converge to an accurate estimate in the fastest possible way. Now, that represents kind of a popular belief that when you use an algorithm to process a data set, you need to understand whether the complexity of the algorithm matches the complexity of the data. But having said that, there are also some recent work in the deep learning realm that basically says that, wait a second, this may be true for the traditional algorithms that we use, but for deep learning, there's another phenomenon that would occur. Like this paper from 2019 actually shows that sometimes a over-parameterized algorithm, meaning that the algorithm has way more parameters than even the data that you have, even the number of records that you have in the training data. Even in those cases, well, the algorithm may still perform well. Okay? So that defies our traditional understanding of how the bias variance trade-off would work or how overfitting would affect the performance or the accuracy of algorithms. And that's the reason why I said at the beginning that for the second point, of algorithm complexity, there's really not a simple recommendation as of what exactly we can do to address the robustness issues. The literature on this has not converged, has not stabilized. The only thing we can say is that different algorithm would function differently on different data sets. So it's very important to look at specific data sets and then find an algorithm that works the best for it. Just like, we would not use a ruler to measure the distance between two airplanes. We use radar for that purpose. For different data sets, for different complexity of the data sets, we use different algorithms. And it's important to understand that when we design a data analysis workflow over a large scale organic data set. So I know I'm 5 minutes past 10:40, but this is the 3 points that I would like to, again, hopefully deliver in this talk. And thank you very much.
Well, we have some time. If you want to, go into details into your last slide, that's fine.
Last one, you mean this one?
Sorry?
Well,
yeah, I didn't want to rush you. I didn't want to rush you just because we started late, so you're not past your time.
I see. Okay, so I would maybe use 1 more minute to explain what this slide is about. So this slide shows a very interesting, intriguing result, which defies our traditional understanding of how the complexity of an algorithm affects its robustness. If you look at the x-axis here, the x-axis is basically the number of parameters used by a machine learning algorithm. So our traditional understanding is that as the value of x on this figure goes to the right, which means as the value of x increases, the complexity of the model increases. Now, the error, which is what you see on the y-axis, should initially go down and then go up. Why is that? Because initially, as the model becomes more and more complex, and it slowly matches the complexity of the data. When the two matches, that is the point where you should see the lowest error. So this point right here, according to maybe x equal to 10. So 10 parameter is about what you're going to see as the lowest possible error, the red curve, the lowest point here. And then as the model continues becoming more and more complex, its complexity exceeds the data. Right? So the data is not that complex, but the model is very complex. So there will start to be overfitting, and then you will see the error goes up again. So that's our traditional understanding. When the model complexity fits the data complexity is the best. If the model complexity exceeds data complexity, and then you get bad results once again, because robustness gets worse. Now, what this paper shows is actually a very interesting result, is that's not the whole story. Once the model complexity exceeds a certain threshold, as you can see in this case 40, it goes down again. So that defies intuition, because intuitively we would think, as the model becomes more and more complex, the robustness will become worse and worse, but not so, according to this study. When the model becomes so over-parameterized, well, it actually generalizes well again. Robustness issue disappears, at least for the deep learning algorithms that they tested. Why? Well, there are some explanations in the literature, but we don't have a converged or stabilized answer that we know is true. This is still a very active research area. To put it simply, we don't really know whether this phenomenon persists for all data sets, for all algorithms. We know it appears for some data sets with deep learning algorithm. So the important thing is to understand which segment or which part of the curve you are at when you are using an algorithm to process the data. You want to avoid this 40 parameter case, right? You don't want your model to fit the data very poorly. As of whether you fit the complexity perfectly to get to the 10 case, or you just simply have an over-parameterized algorithm, which also delivers robustness well with the 800 case. Well, right now we don't have a clear answer as of which one is better. So that is the slide I want to clarify a little bit. So do we take questions now or until the end of the today's?
Yes. I was thinking to do a Q&A after each presentation so that everything is still fresh. Thank you very much for this amazing presentation. There was definitely a lot of complexity with this, using these organic data. So thank you for all the information you've provided. We have a couple of questions. The first one is, do you think the robustness problem in organic data is due to a misunderstanding of the limit of overfitting models?
Well, not entirely. So as I mentioned in the beginning, there are different reasons why robustness issues could arise in analyzing organic data. For example, it might arise if we don't understand the data generation process well enough. Right? Like I said, if we don't know Amazon S3, AWS S3 is behind all these web services, we could mistakenly believe a simultaneous drop of two websites must mean one website is driving the traffic to another website. That's not true once we know more about the data generation process. So that could be a reason that triggered a robustness issue. Now, another reason that could trigger the robustness issue is a mismatch between the algorithm and the data. So once again, overfitting is one possibility, right? You overfit the data that you have, the data doesn't really generalize to any other data set. That could be one reason. But as I demonstrated, sometimes you have a underfitting algorithm, which is, let's say, just use string matching to determine which city a tweet is from. That's just underfitting because the algorithm is too simple to accommodate all the different complexity of how people talk about the city of the tweet. And in that case, robustness issue could arise as well, because Whitney Houston could be the reason why people mention Houston, not the city of Houston. So there are different reasons. Overfitting is one of them, but not the entire picture of robustness issues.
Okay, thank you so much. So the next question is a little bit long, so I'm going to just read through it. From a big picture perspective, can we say that the robustness problem is acute in the analysis of organic data because computer science literature does not provide clear and comprehensive paradigm for research design? For example, in many fields such as economics and finance, there are general paradigms that guide research designs and identification strategies. As such, I'm assuming that if there were general paradigms in the computer science literature for designing these machine learning algorithms, and robustness problem could be unlikely.
Oh, that's a great question. Let me answer the question from two perspectives. One is, why there is no clear paradigm for this kind of methodological use in the computer science literature. And the second is whether there is possible for such a paradigm to be developed in the future. Now, for the first question, the answer is simple, because computer science cares about different things. Computer scientists in developing machine learning algorithms are not really designing the algorithms for it to be used in the pre-processing of data for empirical research. And if you look at how these algorithms were designed, these algorithms were designed for the sole purpose of predictive accuracy. Now, again, when I say for the sole purpose of predictive accuracy, what I neglect to mention is that computer science, as part of applied science and engineering, is constantly making trade-offs. Right? You don't design an algorithm that guarantees you the best result. You design an algorithm that gives you a good enough result in as quickly as possible. So these are not what we would need in terms of having a paradigm that would guarantee the robustness of empirical findings drawn from data. It's designed for a different purpose. It's considering all kinds of trade-offs that, frankly speaking, don't really matter in empirical findings that much. So I think that kind of explains why you can't expect to really see a general paradigm that guide the research the design of empirical research that use these algorithms, because the designers of these algorithms don't have empirical research in mind almost at all when they design these algorithms. But the second part of the question, which is whether there could be such a paradigm in the future. Now, I think certainly no one can predict the future, but if the past is any kind of answer, you don't really see one algorithm fitting all kinds of data. In fact, you don't really know what algorithm would serve your data the best before you start digging into the data. And that is why engineering is almost sometimes an art to find the best algorithm and the best parameterization of the algorithm that deliver the purpose that you want. So let me give you an example. Right? There was a paper published last year, I think, at the European Conference on Recommender Systems, which did an empirical comparison of state-of-the-art recommender system, recommendation algorithms. Now, they compared, I think, 12 algorithms from the recent literature and using real data, and they found that for many of the data sets, the best algorithm is the simplest nearest neighbor algorithm that we knew decades ago, not the deep learning algorithms that were developed in the past few years. Well, this, of course, doesn't mean the deep learning algorithms are useless. It's just different data sets actually call for different solutions. You don't know which algorithm fits which solution the best until you look at the data and you understand the nature of the data. So I am not holding out hope that there could be a general purpose research design guideline in the near future, given just the complexity of the landscape in the algorithm design. It is not the same as hypothesis testing in statistical analysis, because the drivers of these algorithms, the designers of these algorithms, are not concerned with the empirical research question, but motivated by other things like how to deploy these algorithms to do accurate predictions at scale in practice.
Awesome. Thank you very much. We don't have much time, but I just want to ask a quick question. I know it's kind of irrelevant to your talk. For those of us who have never collected organic data, do you have any recommendations on how to go about actually collecting these data? Maybe you could just, in a few minutes, just point us to a few directions of, maybe sources that we can start with to go about collecting those data.
Sure. A lot. By the way, before joining the Juilliard School of Business, I was a computer science professor for over a decade, and one of my research topic back then was exactly about how do you collect the data from the deep web, from web databases. So today, actually, is much easier to do so than 10 years ago, because a lot of web services actually have APIs that allow you to query the database to get the data that you want. Now, if you, let's say, if the data sources that you're interested in has these APIs, then it's usually pretty simple to write a script to connect to the API to get the data that you want. Now, for web databases, for websites that don't have these APIs, sometimes you need to write a script that should download the web page and then pass the HTML and then find the data that you are interested in. I wish I could say that there are automated tools for do so. That has been the goal of the so-called information extraction community in computer science for decades. But there's still no kind of universally deployable extraction tool. So if there's no API, mostly you have to write your personal script in order to crawl data from these websites. But one thing I do want to encourage everyone to look into is the data repositories online. A lot of computer scientists, after crawling data from the web, actually post them on these repositories. You can find, for example, there's a very famous UCI machine learning archive, and so on, a large number of repositories from which you can find many, many different data sets that have been used before. You want Amazon product review data, is right there, someone has done it and they posted the data set, so you can just use it. You don't have to do everything all over by yourself.
That's amazing. Thank you for telling us about those repositories. I should definitely check them out. Thank you so much. I really appreciate you speaking with us today and your great presentation. I'd like to go because we are kind of running a little bit over. Go to the next, our next presenter, Dr. Anglin. Aaron, are you here?
Yeah, I'm here.
Awesome. Thank you for joining us today, Aaron. If you're gonna go right into your presentation, that would be wonderful.
All right. So can you guys see that? I got multiple screens up. Okay. Yeah. I would like to start and say I apologize for throwing the schedule off today. I was clearly told 10 a.m. Eastern Standard Time, and I put it in my calendar as Central Time. So thank you, Nan, for jumping in there and filling in. So that was not on the organizers. That was completely on me. So I was asked to talk a little bit about crowdfunding and crowdfunding data and the different things that you can do. So I've got a presentation titled, Opportunities and Challenges of Crowdfunding Data. So I'm primarily an entrepreneurship scholar. And I study new venture finance topics. And one of the hottest topics in new venture finance revolves around crowdfunding. So most of my work uses crowdfunding data or different types of crowdfunding data. So I assume most people have some concept of what crowdfunding is nowadays, but just in case, I'll cover what it is really quick, or the rest of the presentation will make no sense. So crowdfunding basically is when a lot of people come together to fund something. So the crowd. This is often a particular project. It can be a company, it can be a person, it can be a nonprofit, and there's people do fund lots of different types of phenomena with this. So a lot of people are familiar with Kickstarter. On Kickstarter, basically, if I wanted to create a new drone, let's say I'm a new company and I create drones, and I need $15,000 to create this drone. I can go to Kickstarter, create a profile, ask for this $15,000, and I have to incentivize people to give me money. Often I will give them the drone as a reward or company merchandise or something like that. Crowdcube allows you to buy equity in companies. Fundrise is real estate. People can actually crowdfund real estate investment. Upeffect is for social ventures. But anyway, there's a lot of different types of crowdfunding. Depending on what people want to fund. So you'll actually see crowdfunding data all across management research. You'll see it in all the major journals now: AMJ, JBV, SMJ, JP. Most of the work is really in entrepreneurship. That's not particularly surprising. I mean, at the end of the day, we talk about theory and data and all this, but we study phenomena, we study people, and the invention of crowdfunding has affected entrepreneurial phenomena more than anything else. And it's actually become the #1 source of startup capital for new ventures. For decades, it was venture capital, measured in dollars. Venture capital, though, only 1/4% of entrepreneurs will ever get it. So the fact that people can use crowdfunding and there's no limitations on who can use crowdfunding has made it an absolute game changer for entrepreneurs across the world, which of course, as entrepreneurship scholars, we care about that. So it's used to answer a lot of different micro-oriented, macro-oriented questions in entrepreneurship. However, you'll see it in strategic management too, particularly around strategic choice, people that research strategic choice, as well as institutions. There was a recent SMJ published on how institutional infrastructures were built differently among different types of crowdfunding platforms. You'll see a little bit in OB or OBHR literature, not probably the least, but basically so much of crowdfunding revolves around evaluating other people, looking at how they speak, how they talk, what kind of information they're presented, and then people have to make evaluations and judgments on that person. So that's really kind of how you see it in the OB literature. Finally, marketing and finance have taken up the crowdfunding call. they're a little bit late to the game. Interestingly enough, they kind of ignore most of what's been done in management, but they're finding the same stuff that we are, which is good, I guess. So probably the biggest opportunity for crowdfunding data is it's really easy to get. It's very easy to get. So if you're interested in these types of phenomena that I just talked about, or entrepreneurial phenomena, you're not going to have a problem collecting data and collecting large amounts of it. So most data is scraped, but there are websites, web robots that actually does scraping as well, and they just post it. So they literally run a crawler once a month and post the crowdfunding campaigns from that month. They're not as complete as a data set you might scrape yourself. But if you have any, given this is a research methods group, I know a lot of you guys are probably good with Python and things. You can run a pretty simple crawler and collect literally hundreds of thousands of observations in a week. Kiva data, which is a popular microfinance platform, is public. So they have their API and you can just query whatever you want and download it. They used to provide CSV files of all their loans, but that's stopped working and they're updating whatever that means, how they're going to share their data. But the API is still public, so you can query whatever you need. If you do have to hand collect some things, it's not terrible. I've done it for my dissertation. I had to hand collect a lot of variables. You can probably code 1,000 campaigns in a couple of weeks, so it's not terrible. And once you scrape it, collect it, comes out really nice and neat in a spreadsheet just like this that you can upload in this data or SPSS or M+, whatever you use for your data analysis. So the flip side of that, probably one of the biggest challenges is because it's so easy to get, you get no like cool data points when you're submitting papers to journals. Years ago, when people first started researching crowdfunding, and they would have 60,000 observations, and it was almost shocking to see, because we know entrepreneurs, they never fill out surveys, they don't like to participate in experiments. Getting data was really hard. So there's almost like some, I don't know, cachet you would get if you had a crowdfunding data set. Those days are over. So I consider crowdfunding data to be akin to like CompuStat now. There's a lot of variables that you can get, that you can scrape, but you got to do something else if you're going to publish with it. And so we always go back to those same old things that you'll hear in doctoral consortiums time and time and again. What's your research question, theoretical contribution? You can't lose sight of that just because you have 100,000 observations. So I'll run quickly through the different types of data you can collect and how you might even expand the data set. But this is just a standard Kickstarter campaign. And so depending on your interest, there's a lot of different things that you can pull from the campaigns themselves or from the websites. So if your video metrics is becoming more and more common as we communicate virtually, like we're doing right now, how people do that and the techniques they use can be captured through video metric software. I recently published a paper looking at different emotions, and we were literally measured frame by frame the facial expressions of emotion using video metric software. It's clearly a lot of performance data for, I guess, more strategy-oriented folks. You can see how much money is raised, how many people support them, whether they met their goal or not. All the temporal data as well, like how long things take, when they were launched, what time they launched, what time zone they were launched in. A lot of connection to social media. So social media is a huge part of really drumming up support for a crowdfunding campaign. So you'll see people build, they'll run simultaneous Twitter campaigns, things on TikTok, Facebook, Instagram, all trying to drive traffic to the site, and that just creates more data that you can collect there. Clearly, a lot of textual data. I do a lot of content analysis work, and there's a lot of text that is on crowdfunding campaigns. It's basically a visual and basically it's a video and written pitch. So also data on incentives. So in rewards-based campaigns in particular, or equity-based campaigns where you're buying into a company, people are incentivized to do something. So if you're interested in incentives and how incentives shape behavior, you can literally see how entrepreneurs or people using crowdfunding are trying to get people to act in a way that they want. So ton of media data as well that you'll find connected to these sites. So when entrepreneurs are going to launch a crowdfunding campaign, they often do these media efforts in advance to try to drum up support. And so these campaigns, these companies will get written about. They'll be featured in Forbes or TechCrunch or popular blogs, and then they'll link that to their site. Information on reviews, values, and visions, if you're into leadership type topics, or as well as a lot of social responsibility. We know that people like to support socially responsible companies through crowdfunding. Actually, a lot of platforms encourage people to talk about their social responsibility because of that. So if you're interested in social responsibility, there's a lot of information on that. Interestingly enough, like, you can't really verify the information on social responsibility. So it's really about social responsibility claims. So, and of course, people. A lot of us study people. At the core, I guess we all really study people. So there's a lot of information on these websites about founders, what they've done in the past, what their experience is. Often there'll be a team, and they'll talk about the different things that the team brings to the table. As you can see here, a lot of pictures. So let's say you're concerned with or interested in, say, team diversity and how team diversity shapes particular outcomes. Well, you can literally look at this in code. Okay, this team right here, they only have one woman involved, right? So there's a lot of the basic diversity measures that you can just capture straight from the website. So that most of that is just in the portal, but there's really an opportunity to build very, very expansive data sets based on what is on the platforms. I mentioned, I do a lot of content analysis work. You can build really extensive sets of different constructs that are used in crowdfunding with just basic software like the Luke software or CAT Scanner in Vivo. You measure things like expressed entrepreneurial orientation, emotions, things that are reflective of personality, communication styles. There's actually a lot of work coming out on communication styles right now. One of the things that's also pretty valuable is you can develop and validate your own measures. Bag of words, content analysis approaches have been used a lot, but you're starting to see more and more machine learning algorithms written to capture certain constructs. And of course, to train an algorithm, clearly our first presenter would know much more about this than me, but to train an algorithm, you need data. You need a lot of data, and of course you have that. You can feed in 100,000 campaigns with text all longer than 300 words to really train an algorithm for what you're looking for. You can combine, so I mentioned the video metrics, but facial recognition software can be easily applied to the videos. And you can kind of capture things anywhere from like emotions and mannerisms. There's a new paper that came out on voice, on how people speak, to attractiveness, different facial features, essentially what people look like when they're presenting. And in these low information settings where I'm pitching something online and 100 people, maybe they're going to bat me, maybe they're not. These minute details matter. How people are speaking really matters. And of course, because you can kind of build these massive databases, if you need to go in and if you have a theoretical framework that you need to go in and code for, it's usually not that hard to figure out how to do it. For example, I just published a paper. Think back like 9th grade English. What composes a story, characters, conflict, those sort of things. Use this narrative theory framework to go in and code how people were telling stories. And it's really relatively simple to do. I mean, a couple other coders did it. Again, you can code things like team compositions and those sort of things. So a lot of this can be combined, or this data can then be further combined with other sources as well. I mentioned there's a lot of media coverage that happens with these campaigns. So you can use things like LexisNexis or Lexis Academic now to pull different types of coverage for these entrepreneurs, coverage they got before the campaign, coverage they got after the campaign. For example, there's an interesting paper in Org Science that just came out, Murray and Fisher, where they showed that entrepreneurs who talk a lot in the media before their campaign to drum up business often start to make claims that they can't deliver on. They start to make promises that they cannot deliver on. And so once they get into the campaign, they end up disappointing people because they cannot live up to the promises they made before the campaign. You compare it with like landmark events, like right now, working on a study that looks at LGBTQ issues on crowdfunding websites. A lot of people openly identify and talk about their identity. And we know that there's different types of media coverage that's occurred over the last decade, where there's events that are pro-LGBTQ and anti-LGBTQ. And how does this end up shape, this national sentiment shape the way people respond to these folks on crowdfunding websites? Of course, you often know the location. You know exactly where these people are located to a certain degree. Like, I will know if an entrepreneur is in Alabama. I will know if they are in Switzerland. And so often the economic environment around where these people are located influences how the money flows into them. So you compare it with state and country level data. Had one study where we looked at how small business owners used GoFundMe during COVID to fill resource gaps. And so one of the things we had to add was state level COVID infections, but which was relatively easy to pair because we knew what state they were in. And of course, any kind of qualitative data. Entrepreneurs in general don't like to talk to researchers, but they will sit down for interviews if you allow them to talk about themselves a lot. Obviously, you see who these people are. You know what their email address is. You know their Twitter, their Facebook. So you can reach out to folks, and some of them will talk to you for interviews and tell you their story. And one other way you can kind of build on these instances is network analysis. Now, I'm not a network analysis expert at all, but I know this is starting to become used more and more in crowdfunding data. With crowdfunding data, and the reason being is we know that there's these loose networks that start to form on these platforms where people will support each other. So one entrepreneur launched a campaign, people supported her, she will then support the people that supported her, but when she does so, she kind of brings another group of people with them. So there's these loose networks that kind of form. They tend to form around certain topics like tech or women's issues or different social causes. So I've started to see people use this network analysis to kind of determine how these things flow, how they work, who's funding who, and answer questions around that. So while you can build these expansive data sets with crowdfunding data and all the I guess stuff that gets generated around it, one of the things that's really, really, really tricky is data on perception. And so I mentioned earlier that a lot of this is about judgments. We're seeing what people are putting out online. We're seeing what they say in their video. We're seeing what they say in their words, and we're judging them. And a lot of that depends on how we perceive them. But we don't know often how backers are perceiving certain qualities. So one of the ways we get around that is through online experiments and surveys. And Prolific and MTurk fit well here. I know sometimes Prolific and MTurk can get a bad rap. People are like, oh, well, people are just going online and just clicking on things and answering surveys. In that case, yeah, they are. Just like crowdfunders do when they fund a company. So it's easy to use these platforms to construct, either to use campaigns that are already out there and manipulate them, or to construct campaign pages that look just like something you would see on a particular platform. And when you do that, people can then go on, they'll evaluate them in a few minutes and make a decision on whether they would fund them or not, which is exactly what happens on crowdfunding websites. Again, we know people don't debate for days whether they're going to give $50 to a crowdfunding campaign. They look at it, they make the decision right then. So the same thing, you can pretty much mimic that with Prolific or MTurk. And then our real clean manipulations to do that too. So this is actually taken from a study that I've actually done, and we're just manipulating age. So if you look at the lady in the corner there, or on the right hand side there, we use AI just to manipulate her age, but the manipulation is real clean because we can make everything the same except for her, and that is the same person. We're just using AI to manipulate her age. So if you're going to use these online platforms, though, it goes without saying, you got to be real careful. When you use Prolific or MTurk, bots and lazy workers are a problem, and they can really mess up your data if you're not careful. So I always recommend that people keep their studies very short. People are looking to do this quickly, so keep the study short. Have screening questions. Use defenses against bots, whether it's, people say they're not a bot, solve a little puzzle, whatever. There's a lot of folks on these websites that will train bots to just go in and take surveys, and you can see it because it'll just be a straight line A's all across, marking A all the way across. I always have at least 2 attention checks, one kind of near the beginning, one near the end. Timers are a big deal. Even when people get into your survey or the experiments, not everybody is taking it seriously. And so once you've judged, say, among your author team, this should take about 2.5 minutes. It should take about 5 minutes. When you see people go in, they've taken 25 seconds. Well, you want to have some sort of cutoff where you can get rid of some of those observations. Sometimes, Qualtrics will allow you to do survey codes that you can then go enter back into MTurk or Prolific when they get to the end. So people have to actually finish the survey, but you're going to lose some data no matter what you do. So just be prepared for that. If you need 2,000 responses, maybe you seek 3,000. There's debate on whether you should just pay everybody that takes it or not. I think some people just pay no matter what. I don't. If I'm not going to waste money on, the university's money on people giving me crap responses. But if you do reject payment, just be prepared for some hate mail. I've literally had people email me, say they're going to burn my house down because I didn't give them their $1. So just be prepared for that. Just a couple other quick things to know about crowdfunding data. If you're going to use it, none of this stuff is normal. It's all skewed or bimodal. So when you're fitting models and algorithms, just be aware of that. So make sure you're employing the proper transformations if you need to. Check sensitivity to outliers. Robust ended errors are great in this particular case. Check your residuals. I'm surprised of how many papers I review, and no one has checked any of this stuff. And I can clearly tell from the model that they put in that there's going to be issues. Also, you cannot assume generalization across platforms. So again, crowdfunding is really more of an umbrella term to describe a lot of different types of funding. And they have their own unique ways the pitches are presented. People come to the platforms for very different reasons. And so often what works in, say, a Kickstarter context will not work in a Kiva context. So you need to understand the nuances of the type of platform that you're working with. Some of the really early work in crowdfunding makes this mistake where they just call everything crowdfunding, but that's not the case. So quick example. So on Kickstarter, like I talked about earlier, people are coming and it's a for-profit company, and they are often doing product designs, and people expect to get something if they give money. On Kiva, it's a micro lending platform that essentially funnels money from the Western world into poorer nations like Honduras or Kenya or somewhere like that to help people start and grow businesses. These are loans. They're probably asking for $400 or $500 at the most. The contributors expect to get paid back, but they don't get anything for it. They don't get any interest, and they're coming there with very socially oriented motives. They're not really coming there because they want to get something. And so that's a very, very different, driver of funding decisions. Continuing with that example, videos are huge on Kickstarter. Just having a video is a major predictor of success. There are no videos on Kiva. There's only just one picture, and that's it. So the campaigns are designed very differently. Performance is often assessed very differently. Again, with Kickstarter, people tend to look at things. Did you meet your goal? Did you, how much money did you raise? In Kiva, almost everything gets funded eventually, and Kiva sets it up that way. So people look at things like, how fast did you get funded? That said, there are some things that do generalize. And if you think that your story is broader than a particular platform, because this data is pretty easy to get, well, you can test that. And we will see certain things, like one paper I had talked about language reflective of psychological capital, and that generalizes across platform. People like that. People like for you to speak confidently, optimistically, hopefully, and show some resilience across the platforms. Things like entrepreneur orientation don't generalize well at all, which is interesting. You guys are research methods folks, so I probably don't need to say this, but still make sure you're doing your standard checks for endogeneity. Omitted variables is an issue sometimes. Sample selection issues, depending on what your research questions, can be an issue with crowdfunding. Like, people are making the decision to select into crowdfunding for particular reasons. We actually know with equity crowdfunding that people select in often because they can't get money anywhere else. So it's a last resort. So often the quality of those companies might be very different than, say, what an angel investor is looking at or what a venture capitalist is looking at. So there are some sample selection things that you just need to be aware of when you're figuring out these contexts. So that's basically what I had for you on crowdfunding data. I guess I'm happy to answer questions.
Thank you so much, Aaron. That was a great presentation with a lot of information on different things that we could do. So thank you so much for the information. So I have a few questions in the chat, and if anyone has any additional question, please feel free to enter. So the first one is, when evaluating the content of the campaign and how the campaign is delivered to the audience, and due to heavy scripted nature and production involved in crowdfunding efforts, is there potential concerns with trying to deal with inauthentic information about the entrepreneurs and founders? Yes,
absolutely. And sometimes that matters, sometimes it doesn't. So if you're trying to get to the actual motives behind the entrepreneur, yeah, that matters whether they're being authentic or not. If you're just looking at how the pitch itself resonates with backers, well, even if they're not being authentic and they come across optimistically, that still matters, right? Even if they're really nervous and they're not optimistic about the venture, if they come across optimistically, that still matters. So yeah, there's certainly concerns about people being inauthentic, and I'm sure that they are, and you don't always know. But yeah, it kind of really just depends on what your question is, whether that would affect your study. In a lot of cases, it just simply doesn't matter, and there's a lot of impression management that goes on.
Thank you. So the next one is, in studying decision-making with crowdfunding data, how do you deal with the impact of the reward on the decision-making process as compared to the campaign itself?
Yeah, so generally, at a minimum, you introduce controls for the types of rewards and different reward amounts. We actually know that offering more rewards in and of itself can help drive more money. Another thing you can do in kind of indirectly is you account for campaign categories. So technology campaigns tend to have similar types of rewards. Artistic campaigns tend to have similar types of rewards. So accounting for the campaign category gets at it too.
Awesome. So the next question is, have you ever encountered potential licensing issues with using content from actual campaigns? I used product images from Kickstarters for my experiments, testing product evaluation. I'm concerned there may be issues with that. I've been working at whether Kickstarter or other crowdfunding platforms allow content use, but it's not really clear.
I've never encountered any licensing issues. I think when people put these things, they're putting themselves out there, and this is very, very public. So I don't think people are going to be surprised if their pictures or something get used elsewhere. And media, when they get media coverage, I mean, these writers will just pick up the campaign and just start writing about it and use their images and everything, and they don't ask. So I've never really encountered those issues. And again, it's public. It's like putting something, like having a public Instagram and putting a picture out there. Somebody might use that. So
yeah, they might even like it, right?
Yeah. So,
to have more coverage. Yeah.
Yep. And of course, Kiva actually makes theirs public for research. So they're told, like, if you're on that site, people literally know that you can be researched.
Awesome. Okay, is there a way to capture failed campaigns? I know Kickstarter no longer publicly archives these unless you have the live link.
Yeah, and you kind of have to have the failed campaigns. Only about 35%, I think, are actually successful in the end, which is actually a high percentage for entrepreneurs. Usually more companies fail than that. Yeah, generally the crawlers can go and look back in time and pull those. I've never had an issue. I'm not that great at scraping, but my co-authors that do a lot of that don't have issues finding the failed campaigns. Another thing you can do too is one guy I know does 2 waves of collection. Like he'll run at the beginning of a month, collect all the live links that are on there, and then 30 days later, because most campaigns are about 30 days, he'll go back and rerun all those links, and he's got the links. The links are always going to be there. Like I can pull a link from something from 2013, and it's still there.
Awesome. So the next question is there any paper you would recommend an OB researcher to read before designing a study around crowdfunding data? And I extend it to other fields as well, not just OB, maybe macro, or just in general. Anything you would recommend someone reading before designing their study?
Well, I mean, I would just go look at the crowdfunding papers that are published in the journal that you're looking for. So as an OB researcher, you're probably, if you're not targeting AMJ, you're probably targeting JP, I would imagine. I think it's Lee, Fisher, and someone else. There's a paper on passion. It's called A Glimpse into Entrepreneur's Passion or something like that in JP, where they use both field data and experiments to show how passion influences decisions. So that's a good one. That'll be framed, more for an OB audience. Again, with the strategic management stuff, they tend to look at strategic choice, and they're looking at the platforms, not often the individual campaigns. So I think Desnitsky has a paper that just came out. That's a good recipe for looking at across platforms. And of course, in entrepreneurship, you can find, I don't know, hundreds of examples at this point. I don't want to hype my own work, but I think it's pretty good if you want to look at it. So
yeah, your work is awesome. If you have any more questions, please type them in the chat. Otherwise, I think we are kind of at the end of our time. Thank you so much for taking the time, both Aaron and Nan, today to share your knowledge and expertise with us. I really learned a lot from both of you, and I think our participants benefited a lot from the 2 of you. So thank you so much again for coming in and taking the time. If no one else has any questions or has any lingering issue that they want to share. Okay, so the last one. So I've been receiving a lot of emails about the videos. We will record all the sessions for the future ones, and we did record the first 2 ones, but I don't have the links to the videos yet. Once the videos are uploaded on YouTube, I'll share the link with everyone on the participants list. So thanks for your patience, and I'll share that with everyone. So thank you so much for coming in today, and I'll see everyone next week. Have a good weekend.
Thanks for having us.
Thanks for coming.